For most of human history, the night sky looked empty, a sea of distant stars, beautiful, silent, and unreachable. But hidden among those stars are other worlds, some larger than Earth, some frozen in darkness, and some that may orbit in the narrow zone where life can survive. Then, in 2017, astronomers found something extraordinary. A tiny red star, far smaller than our Sun, surrounded by not one world, but seven rocky planets, 7 possible Earth-sized worlds, 7 reasons to ask whether humanity is truly alone. This is TRAPPIST-1. TRAPPIST-1 does not look impressive at first glance. It is not a giant blue star blazing across the galaxy. It is not a brilliant white sun lighting up a massive planetary system. In fact, TRAPPIST-1 is a small, faint red dwarf star located about 40 light-years from Earth in the constellation Aquarius. Its diameter is only slightly larger than Jupiter's, and its mass is less than 10% that of our Sun. Yet this tiny star would become one of the most important objects in modern astronomy, because around it, hidden in the darkness, orbit 7 rocky worlds, one of the most extraordinary planetary systems ever discovered. The first planets around TRAPPIST-1 were detected by astronomers using a method known as the transit technique. As a planet passes in front of its star, it blocks a tiny fraction of starlight, creating a small but measurable dip in brightness. In 2016, the first hints of the system began to emerge. But in February 2017, the full scale of the discovery became clear. TRAPPIST-1 was not home to 1 or 2 planets. It had 7, all of them roughly Earth-sized, all orbiting incredibly close to their star, and several positioned in the region where temperatures might allow liquid water to exist. For astronomers searching for habitable worlds, it was a breathtaking moment. The 7 planets of TRAPPIST-1 are named simply TRAPPIST-1b, C, D, E, F, G, and H. At first, those names may sound cold and mechanical, but behind each one lies an entire world. All 7 are thought to be rocky planets, not gas giants. Several are close in size to Earth. Their density suggests compositions made of rock, metal, and possibly water. Most astonishing of all, the entire system is unbelievably compact. If TRAPPIST-1 were placed at the center of our solar system, every one of its known planets would orbit closer than Mercury does to the Sun. It is not just another planetary system. It is a completely different way for worlds to exist. Astronomers discover exoplanets all the time. Thousands are now known across the Milky Way. So why did TRAPPIST-1 matter so much? Because it gave us something rare. Not just one potentially habitable world, but an entire laboratory of them. 7 rocky planets orbiting a nearby star. Multiple planets in or near the habitable zone. A system close enough for modern telescopes to study in detail. For the first time, scientists had a realistic opportunity to compare several Earth-sized exoplanets within the same system and ask one of the oldest questions in human history. Could life exist there? Not every planet is born equal. Some worlds orbit so close to their star that their surfaces are scorched beyond survival. Others circle so far away that any liquid water freezes into permanent ice. But between those extremes lies a narrow region astronomers call the habitable zone, a place where temperatures may allow liquid water to remain stable on a planet's surface. Around TRAPPIST-1, that zone lies astonishingly close to the star. Because TRAPPIST-1 is so cool and dim, planets can orbit at extremely short distances and still avoid being destroyed by heat. This means several of its 7 worlds fall in or near the region where water, and potentially life, could exist. That possibility changed everything. Because for the first time, we were not looking at one possible Earth. We were looking at several. Of the 7 known planets in the system, 3 have drawn the most attention: TRAPPIST-1e, TRAPPIST-1f, and TRAPPIST-1g. These worlds orbit within or near the habitable zone and are considered among the best candidates for temperate conditions. TRAPPIST-1e in particular has become one of the most fascinating exoplanets ever discovered. Its size and density suggest it could be rocky like Earth. It may receive just enough stellar energy to allow liquid water under the right conditions. TRAPPIST-1f and g are slightly farther out, where colder environments may dominate. But if they possess thick atmospheres, greenhouse warming could still make them surprisingly habitable. Each of these planets is a question waiting to be answered. But habitability around a red dwarf star comes with complications. Because the planets orbit so close to TRAPPIST-1, many of them are likely tidally locked. One side of the planet may always face the star, locked in permanent daylight, while the other remains in endless night. This creates an extreme environment unlike anything on Earth. On the day side, temperatures could rise dramatically. On the night side, they could plunge into deep freeze. Only a narrow ring between light and darkness might offer stable, temperate conditions. Unless the planet has something powerful enough to redistribute heat. An atmosphere, an ocean, or both. Everything depends on what these planets are made of and what they manage to keep. If TRAPPIST-1e, f, or g formed with enough water, and if their atmospheres survive the intense radiation of their young star, then some of them may still possess oceans, clouds, weather systems, or climate stable enough for life to emerge. That is why TRAPPIST-1 matters so deeply. It is not simply a system of 7 exoplanets. It is a test of one of the biggest ideas in modern astronomy: whether Earth-like worlds around red dwarf stars can truly remain habitable. If the answer is yes, then the universe may be filled with living worlds, and some of them may look a lot like these. For years, exoplanets were little more than shadows crossing distant stars. We could measure their size, estimate their mass, guess at their temperature. But their atmospheres remained almost completely hidden. That is now changing. With the arrival of the James Webb Space Telescope, astronomers finally have the power to examine some exoplanets in unprecedented detail. TRAPPIST-1 quickly became one of its most important targets. Because if any nearby planetary system can reveal whether rocky worlds around red dwarf stars hold atmospheres, or something more, this is the one. An atmosphere changes everything. It can trap heat, protect liquid water, shield a planet from radiation, and create the chemical conditions life may need to survive. Without one, even a planet in the habitable zone may be barren and dead. That is why one of the biggest questions about TRAPPIST-1 is not simply whether its planets are the right size or the right temperature. It is whether they still have atmospheres at all. Red dwarf stars can be violent in their youth, blasting nearby planets with radiation powerful enough to strip away their air. TRAPPIST-1 may be a perfect test of whether small worlds can survive that assault. If future observations detect water vapor, carbon dioxide, methane, oxygen, or other key molecules in the atmosphere of a TRAPPIST-1 planet, the implications could be enormous. Not because any one gas automatically proves life exists, but because certain combinations of gases can act as biosignatures, chemical clues that something unusual may be happening on a world far beyond our own. We are not there yet. But for the first time in human history, we are studying a nearby system where such evidence might one day be found. And if it is found, the discovery would change far more than astronomy. It would change us. TRAPPIST-1 is not important because it is nearby. It is important because it may represent the future of one of humanity's oldest questions. Are we alone? 7 rocky worlds orbiting a single star. Multiple planets that may once have had oceans. A system close enough for our telescopes to study. And perhaps, one day, close enough to reveal whether life emerged somewhere else in the universe. TRAPPIST-1 may not be the final answer, but it could be the place where the answer begins.